Good morning, everybody. I hope that your week has been going well. Mr. Weavers has been keeping me informed as to how you guys have been doing. He said he's been having a lot of fun. I wanted to just end the week talking to you guys. I was hoping to be back today, but I'm still sick. I wanted to just end the week by finishing up the notes that Mr. Weavers has been working on with you these last 3 days. So if you could just take out your last part of the metamorphic rock. Hey, you guys talked about how you have this intense heat and pressure. So any rocks that are embedded in a mountain range, for example, hey, are going to change. So when we're talking about slate, hey, you have slate that is not too deep, and it's going to undergo heat and pressure. And then slate rather is going to become phyllite. Okay, and then phyllite will become schist, and in some cases, it will become gneiss. But we have to back up for a second, and as you've already learned, well, where did slate come from? Well, slate had to come from shale. Okay, so shale is the sedimentary rock, okay, that has been buried, and then shale has low-grade metamorphism, which then gives us slate. That's why slate and shale look so similar. And then you see that the slate is then further buried, hey, to make phyllite. And then it gets even more pressurized, and then phyllite's going to become schist. And then you start to really see, hey, these foliated bands in gneiss. So gneiss is kind of interesting because shale, hey, will eventually make gneiss. Hey, but also we said in the beginning, you can actually have granite, hey, that will metamorphosize right into gneiss. So there are not always just one pathway. I'm trying to fit that S in there. Hey, there's not always one pathway for metamorphosis to happen. Notes. I just wanted to briefly go over the textures. I know he's been talking to you a lot about the igneous rocks, the sedimentary rocks, and he informed me that you were up to this part in the notes. So I just wanted to take a few minutes to talk about metamorphic textures. I know we talked about it before I went out this week. And the main thing that I really want to just focus on is just foliation and non-foliation. So you've been using the earth science reference tables in your homework, which we'll go over in a minute, to understand how to find the data, whether it's mineral composition or grain size. I have been checking all of your work, and a lot of you have been doing a great job in resubmitting your work with corrections. So if you are unclear on what's supposed to be corrected, some people have been emailing me, which is fine. I have email. I've been checking my email. I want to make sure that you guys are not confused. And Mr. Weavers informed me that you have a great handle on what you've been doing so far. So if I don't answer questions by the end of this class period, please shoot me an email and I'll be happy to get back to you. So the first thing that I just want to talk about again is foliation, right? And we know that is a feature of metamorphic rocks. So when we discuss foliation, this is basically what it looks like, right? So we talk about having a pre-existing rock in order to have metamorphism. So metamorphism means it's changed. So how has it changed? Sometimes it's a very obvious change. Foliation is an obvious change. Okay, this is a pretty cool scheme of taking a rock like slates, and I know Mr. Weavers has been bringing in some samples. You have slate, okay, that is going to undergo heat and pressure, okay, as we know from yesterday, metamorphism to happen. So going back to this, hey, we talk about foliation, and it's these arrangement, hey, of bands of minerals that have been pressurized. So you have low-grade metamorphism and high-grade metamorphism. The last topic, just real quickly, is non-foliated rocks. The example, hey, would be marble. Okay, so when we're talking about non-foliated, they're not going to show these obvious bands. Okay, we already discussed very briefly that limestone, okay, which is a sedimentary rock, will then metamorphosize, hey, into marble. Okay, and that's what it says right here, right? So we have marble is a metamorphic rock, and then we have it coming from limestone, and limestone is the parent rock of marble. Let's go to the next slide real quick. Okay, and then just to finish up, we talked about quartzite. Okay, quartzite is a metamorphic rock, and it comes from the sedimentary rock sandstone. And we said that quartzite is something that you would find all over Long Island, and that is the most abundant metamorphic rock on Long Island. One of the questions in the homework was, what is the most abundant extrusive igneous rock? And some of you did put quartzite. I think you were confusing what I had mentioned about quartzite. Basalt is the most abundant extrusive igneous rock, and that would be the answer that we'll go over in a second. Or actually, no, you went over this with Mr. Weavers, that basalt is the most abundant igneous rock extrusively, which we know forms on the surface. All right, so then quartzite, we said, comes from sandstone. So you might see something like, all right, well, here's sandstone, and what kind of a rock is that? Remember, you don't have to memorize it. You just have to use a reference chart. Hey, sandstone is a sedimentary rock. Hey, well, sandstone, hey, if it's heat and pressurized, will become quartzite. Hey, quartzite. And again, you don't have to memorize that. You just have to use the chart. And quartzite is a metamorphic rock. We'll do a little practice with some of the reference charts in just a minute. And hopefully any questions that you've had over these past few days will be answered. Okay, so now what I would like to do is just go over the sedimentary rock homework. I did grade all of the questions for this homework, so you have the opportunity to resubmit them if you would like to do that. And that goes for all the homeworks that you've had this week. If anything you got wrong, you can correct and resubmit. So the first question, most rocks that form from fragmental rock particles are classified as C, clastic sedimentary rocks. And we know that you learned clastic means just small pieces of other rock. Clastic is another word for fragments. 2, why is the conglomerate rock shown below good evidence that rocks form from other rocks? Most of you got 1 and 2 correct, and the answer is A. Conglomerate contains some non-sedimentary rock fragments. So you can see things like rhyolite, you can see things like gabbro in there, and we know that rhyolite is an igneous rock and gabbro are an igneous rock. So conglomerate is going to be sedimentary rock. It's classified as a sedimentary rock, but it also does have non-sedimentary rock particles in there. So you could even see metamorphic rock particles in there too, because it's just fragments of all other rocks. 3, the diagram below represents a conglomerate rock. Some of the rock particles are labeled. Which conclusion is made about the rock particles? And that basically reinforces what we said with number 2. The answer is D, that they have different origins. So we know that quartz is a mineral, granite is a rock, limestone is a rock. So hopefully by now you're starting to realize that limestone is sedimentary, granite is igneous, quartz is a mineral, basalt is igneous, and then there's that glue, that cementing agent, which are little broken up pieces of other minerals that are dissolved and you can't see them. Number 4, a lot of you guys got this one wrong and you put B because it looks like that is the part that would have the smallest pieces. Well, when you look at the Earth Science reference table for sedimentary rock scheme, this actually does not exist. That's not something that is there. Okay, so A is the answer. And the reason why A is the answer is because when you look at the scheme, the smallest grain size has a symbol that looks like A. There is nothing that you would see for B. But I think a lot of you picked B because it just looks like it's the smallest, but that's not something that exists on that chart. Number 5, which sedimentary rock is formed by the compaction and cementation of sorted sediments, 0.05 centimeters in diameter? Most of you guys got that right, and it's C, sandstone. You just looked at the chart and found out where it has 0.05 centimeters in diameter. And just remember, compaction and cementation is found in sedimentary rocks, and we call that lithification. Lithification. Next page. The diagram below represents fossils found in bedrock formation located in central New York State. In which type of rock were fossils most likely found? So these are organisms that existed in the ocean. So the only answer that makes sense there is sedimentary rock formed in the ocean. you could automatically get rid of A and B because we know that we're talking about fossils, and fossils only exist in sedimentary rocks. 7, the diagram below illustrates the accumulation of sediments in a shallow ocean basin. So if you are used to just kind of skipping over the beginning part of the question, please don't do that because it does give you information to help you. The sediments at location A would be formed into a sedimentary rock as a result of, so there's that layering, right? It tells you layering, which is called stratification. Stratification. So the answer is compaction and sedimentation because those are the only words that have to do with sedimentary rocks. Recrystallization of rock, igneous. Solidification of molten rock, igneous. Action of heat and pressure, metamorphic. That's how you tackle those questions. 8, which group lists rocks in order by grain size from smallest to largest? All you needed to do was look at the reference chart, and see on the reference chart which one has the biggest pieces, which one has the smallest pieces, and this case is asking you to go to small to large. So the answer there is C. 9, same kind of question. Very repetitive. If you know how to do it once, you should be able to know how to do it, several times. Which one is considered clastic? So you look on the chart, for clastic, and it would be B, siltstone and shale, because that is the size for siltstone and shale, 0.0006 centimeters. Moving along, we're almost finished. You guys are doing great. Happy Friday. I guess definitely miss you guys. Much rather be at school. The diagram below shows 3 stages in the formation of a specific rock. So you're talking about burial. You have that plants and animal remains, that are going to be buried for long periods of time. And we know that when plants and plant remains and start to decay, that can create coal. And there's different types of coal. You don't need to know the different types of coal. But for right now, we know that when a plant is buried over long periods of time, pressure builds up, it will create coal. Number 11, which process led to the formation of thick salt deposits found in the bedrock at some locations in New York State? So if we're talking about salt, the only answer there would be evaporation. Just like a pot of boiling water, like we've talked about, the water boils away, the salt is left behind. Same thing happens in large scales on Earth. And remember, the mineral that is found in salt is halite, and then halite will make things like gypsum and rock salt. 12, which type of rock is represented by the map symbol below? So you had to find this on the chart. And now we start to talk about chemically formed sedimentary rock. So that is B. And when you see this symbol, it's next to chemically weathered sedimentary rocks. And it has calcite in it. And remember, calcite reacts with hydrochloric acid, and it fizzes because it's releasing carbon dioxide. 13, which rock is sedimentary in origin and formed as a result of chemical processes? So again, you look at your chart, chemical sedimentary rock, dolostone, do not need to memorize it. You just need to know where to find it. And then 14, large deposits of rock gypsum, again, rock salt, usually are found where? Any type of evaporating sea. So hopefully you're realizing these questions are repetitive. They're asked slightly different, but if you have the basic understanding, you'll be able to apply your knowledge, and that's the goal. We are up to the next slide, which is 15, which sedimentary rock formed from the compaction and cementation of fragments. Again, there's those words, lithification. And then you see skeletons and shells. All right, well, I know that has to be something that has clasts in it, pieces of other rock. And when you look at the reference chart, limestone can come from organic shells and organisms. It's called organic limestone as opposed to chemical limestone. Chemical limestone comes specifically just from calcite. And then organic limestone is going to have, you can actually see the shells and the skeletons of remains. 16, which phrase best represents coal? And we just did that one. Organic plant remains. Which picture, is going to be chock full of carbon, which is 17, and that would be B. And that picture is found on the sedimentary rock chart. And lastly, The maps below, which shows changes in the distribution of land, there's a little space in there, and water in the Mediterranean Sea region that scientists believe took place over a period of 6 million years. So about 10 million years ago, 5.5 million years ago, and it gives you clues in the picture, evaporation. Hey, and then this last one, about 4 million years ago, hey, the evaporation, and now the sea is starting to refill, right? And we talked about cycles. This is cyclic. This will happen again. This has happened in the past. And finally, the question, okay? So you got to do a little work before we get to the question. Which type of rock was precipitated from seawater as the Mediterranean Sea evaporated between millions of years ago and 5.5 million years ago? And the only answer there is rock salt, hey, because all of these other ones do not have anything to do with evaporated seawater. Okay, so those are the answers to that homework. Again, if you want to resubmit, feel free. This was the practice test, okay, that I went over. I will give you the answer key for this. Some of you emailed me and said, which questions did you actually grade? I graded 10 of them. I graded 1, I graded 2, I graded 6, 8, 9, and 10. Okay, and I put in the comments on all of your homeworks, hey, which questions I graded. So you'll see if you got an X next to it, that's one that you got wrong and you can recorrect, or you could correct. But I will give you the answers to all of these questions. I will, publish the key by the end of the day just to give everybody some time to correct. Okay, next page. Can't see the questions, sorry. Hey, I also did 14, I did 15, I did 17. And then I also did number 1. Okay, so those are the ones that I did grade. And if you're not sure, if I went a little too fast on that, you could always rewind this. I'm going to give everybody the link for this, so you can correct. I circled this on a lot of your papers because some of you did write the correct answer, okay, and wrote false, but you're supposed to correct it, right? Make that sentence true. So lots of things that you can go back and get some extra points for if you choose to. And that's the goal, right? So you guys have done a great job. I'm really proud of all the work that you've done this week with Mr. Weavers. So if there's anything you want to go back and correct, you can. Let's go to the next slide. This is your homework for tonight. Okay, metamorphic rocks. This is the last little bit, okay, that you have to do. And you want to answer these questions. Okay, and hopefully it brings everything to full view. Hey, you do not have to do these questions if you don't want to. Hey, however, these are bonus points. So if you want to do the written section, hey, there's an opportunity for bonus points. Everything else is just multiple choice, and you can submit that to me. Same thing over here. There's an opportunity for bonus points if you want. Okay, if this went too fast, everyone will have the link. You can go back and rewind to parts that you needed to hear again. Okay. Please shoot me an email if you have any questions. And have a wonderful weekend. Have a great 3-day weekend. Again, I'm sorry that I haven't been there, but hopefully everything's been great because Mr. Weavers has been teaching you and you haven't missed instructions. That was my goal. I definitely did not want you to miss instruction, even though you might have liked the study hall. Again, I'm here. If you have questions, email me. All right. Have a good weekend.